So this video is going to show you how to do monohybrid punnett squares. Now, mono, as you know, means one, hybrid is a cross. Now, when we look at monohybrid punnett squares show you probability. So remember, we get half our gene from our mom and half our gene from our dad. So a punnett square shows you the possibility of having a child with certain. So when we're looking at a monohybrid punnett square, we are looking at just one single trait. So for example, we're looking at a mom who might be big T, little t, and we're looking at a dad who might be big T, big T. Remember, for every trait that you have two alleles. And so therefore, in the law of segregation, we know that these alleles are going to split up. So in the mom, one egg is going to get the big T, and one egg is going to get the little t. Okay. Same thing is true in the dad. They are going to split. So let's say that these two people, a heterozygous mother and a homozygous dominant father, have children. Okay. We're going to do a monohybrid punnett square, okay, which means we're going to look at one trait at a time. Now, I always remember 2 times 2 is 4, so I know that I'm going to have 4 boxes. Now, you can think of this as representing egg 1, and this represents egg 2. This represents sperm 1, and this represents sperm 2. Now it doesn't matter. I always do the first choice on the top. So egg 1 got a big T, and egg 2 got the little t. And so then on the father, sperm 1 and sperm 2. Even though sperm 1 and sperm 2 look the same, they are 2 different parts of the recipe. Now, when you're doing monohybrid punnett squares, it doesn't really matter what letters you use. I just always use letters that don't match. And what I mean by that, you can tell the difference between a big T and a little t. Okay? You can't really tell the difference between a big O and a little o. So that's not a letter that I would choose to use. And then you just simply go in and you fill it in. So this kid, these are the chances of the children. Now, this does not mean 4 different kids. This one punnett square is one child, and this shows you probability. So when we look at this punnett square, we see that they have a 50% chance of having a child that's big T, big T. And they have a 50% chance of having a child that's heterozygous, big T, little t. That's what we call the genotypic ratio. When we look at the genotype, remember we're looking at what do the genes look like. So the genotypic ratio here is 2 to 2. They have 2 chances, or 50%, of having a child that's big T, and they have 2 chances of having a child who's big T, little t. Now, if we want to look at their phenotypic ratio, okay, phenotypic is what the child actually looks like, tall or short. Notice there is a 100% chance of having a tall kid. All the boxes have a big T. So therefore, 4 to 0. They have no chance whatsoever of having a child who is heterozygous, who is short. So now let's look at another example. Let's say that this mother or this father, they are both heterozygous. So let's say big T, little t times big T, little t. So again, 2 times 2 is 4. So we're going to draw our punnett square with 4 boxes. And again, law of segregation states that when egg and sperm are made, these alleles separate. So one egg gets the big T, and one egg gets the little t. And the same thing happens with the sperm. One gets the big T, and one gets the little t. Now remember, this one box, this one square represents one kid, so we're looking to see the possibilities of what this child might be like. And you just go in, so big T, big T, big T, little t, big T, little t, little t, little t. Now right here you can see, okay, I always put the capital letter first, just like you would in a sentence. It just makes it easier for you to see what's going on. Now, when we're looking at this, we're going to look at the phenotypic and genotypic ratios again. Remember, the genotypic ratio is what do the genes look like? So up here, we're going to do the genotypic ratio. If I can get my pen working. We're going to do the GR. Okay? And with genotypic ratio, you look at the letters. Okay? And you want to see how many boxes have these letters. So we're going to start here with big T, big T. Okay? There's only one box that has big T in it. So up here, we're going to put a 1. We then go to the next box. There's 2 boxes that are big T, little t. And then there's 1 box that's little t, little t. So in this case, our genotypic ratio is 1 to 2 to 1, meaning I have a 25% chance of having a kid who's homozygous dominant, big T. I have a 50% chance of having a kid who's heterozygous, big T, little t. And I have a 25% chance of having a kid who's homozygous recessive. Now we can look at the PR, the phenotypic ratio, which is basically, let's just use the example tall and short. Okay. What are the chances that I'm going to have a tall kid? Now remember, to have the tall gene, the tall allele, you have to have a big T. So if you notice, I have a big T, have a big T, and I have a big T. So therefore, I have 3 chances, or 75%, of having a child who's tall. This one here has no big T whatsoever. So therefore, I have a 25% chance of having a child who is short. So with monohybrid Punnett squares, again, this is just showing you a prediction. It's showing you the probability of having a child with a certain trait. There's lots of examples that you can find on the internet to help you practice with Punnett squares. So, good luck.